Hope everyone's day is going well so far. We are going to keep going on chapter 5 today. I'm going to start with just some kind of FYI things. So these are kind of memorization points, and then we'll keep on going with stuff that has a little bit more intuition to it. So what we were talking about last class was price elasticity of demand. And again, just as a quick refresher, elasticity is this way for us to measure how responsive either the quantity demanded or the quantity supplied is to a change in some other thing. And so we were thinking about the some other thing as being prices. And so last class we were kind of grappling with, okay, if the price of something changes, then how do we quantify the extent of how much consumers respond in terms of their quantity demanded? Okay, so here is kind of, I'll put things to note. Okay, the first thing to note is if you have a linear demand curve. Okay, what is a linear demand curve? A linear demand curve is a demand curve that is a straight line. So it's not like bowed in or bowed out. It's just a straight line. Then what is going to be true is that there's going to be a constant slope across the whole line. So the slope from here to here is going to be the same as the slope from here to here. Okay, the reason I'm pointing this out is because last class we said there's a relationship between the slope of a demand curve and elasticity. So in general, kind of goods that have steeper demand curves have more inelastic demands, and then goods where the demand curve is not super steep are kind of typically characterized as having elastic demands. Okay, the reason I'm pointing this out is because along the same demand curve that's linear, so the slope is the same everywhere on this demand curve, different portions of the demand curve are going to have different elasticities attached to them. So this is important because you should not, in your mind, kind of think that slope is the same thing as elasticity. It's not. There's a relationship between the two, but they're two very distinct things. So even when the slope doesn't change in a line, the elasticity can change across the line. Okay, so let me write out kind of the pattern of how this will work, and then I'll draw you a picture. So the pattern, or actually let me write, change this to an arrow. Let me change this to the thing you need to know. So different price elasticities exist, so backwards is exists, on different parts of a even a linear demand curve. And this will also be true of nonlinear demand curves, but it's a little bit more stark to think about this in terms of a linear demand curve because the slope isn't changing, but the elasticity is changing across the demand curve. Okay, so now bullet points. So points along the demand curve with a high price and low quantity have elastic demands, and then vice versa. So points along a demand curve with low price and high quantity have inelastic demands. Okay, now the picture. So for the picture, I want you to think about, actually I can use that picture. Okay, redraw this in your notes. So have a demand curve that's linear. Okay, so what is going to be true is that on the upper portion of the demand curve, okay, what is true about the upper portion of the demand curve? So for dots around here, the price is kind of high, quantity is kind of low, so we're in this world. What is going to be true up here is that the elasticity is going to be larger than 1. So again, we're going to put epsilon for elasticity is going to be larger than 1. If you have an elasticity that's larger than 1, that means you're in the world of an elastic demand. if you're on the second half or the lower portion of the demand curve, where the price is low, quantity is high, so kind of for this dot right here, quantity is kind of high, price is kind of low. In this lower region of the demand curve, the elasticity is going to be less than 1. Elasticity less than 1 coincides with an inelastic demand. Okay, for the sake of time and not boring you, I'm going to leave this for you to kind of mentally disentangle if you want to like go through actual numbers. So what you can do is you can get out a piece of paper, you can draw a linear demand curve, you can plot 2 points up here, calculate the elasticity for those 2 points, and you should get an elasticity greater than 1. You can pick 2 points down here, use those to calculate an elasticity, and you should get an elasticity less than 1. But for the sake of the lecture and kind of brevity, I'm just going to say you need to know this. So for upper regions of the demand curve, a linear demand curve, elasticity can be will be greater than 1, and for lower regions, elasticity will be less than 1. Okay, so that is kind of thing to note number 1. Thing to note number 2 is there are special cases of elasticity, price elasticity of demand. Okay, so we're going to label this special cases. And the first special case we're going to consider is the case of a perfectly inelastic demand. Okay, so elasticity, again, it kind of exists on a spectrum, so we're thinking about kind of like how responsive people are to price changes. If you are in a world where they are perfectly unresponsive to a price change, then that is going to correspond with a perfectly inelastic demand. So generally, we said what characterizes a good where people are insensitive to the price in terms of the quantity demanded. Well, what is typically true in those situations is that the demand curve overall is pretty steep, and then the steeper it gets, the more inelastic they are. So a perfectly inelastic demand is like the steepness gets steeper and steeper and steeper and steeper until you get to a vertical line. Okay, so this is going to be an inelastic demand. If it keeps on tilting, so you get to a vertical line, and that's what your demand curve looks like, then this is going to be a perfectly inelastic demand. Okay, what is going to be true about a perfectly inelastic demand curve? One is that graphically you're going to have a vertical line for the demand curve. The second thing that's going to be true is that the elasticity, the epsilon, when you calculate it, is going to be equal to 0. Okay, think about why that's the case. Elasticity is the price elasticity of demand is the percent change in the quantity demanded over the percent change in the price. If people are perfectly unresponsive to price changes, then that means you can move the denominator up as much as you want. Like you can have a huge change in the price. But if people are perfectly unresponsive to price changes, then how much is their quantity going to change? By nothing, because they're unresponsive. So in that case, the numerator will always be 0. The denominator could be any number. But whenever you have a numerator that's equal to 0, the whole ratio is going to be equal to 0. So anytime you calculate an elasticity of demand and you get a 0 that spits out, know that you're in the world of a perfectly inelastic demand. Okay, so that's going to be what's true of the elasticity number. What's going to be true of the slope of the demand curve is that the slope of the demand curve, I've already told you this, but I want to make sure it's in your notes, is going to be equal to infinity. So a vertical line has a slope of infinity because you rise a lot, you run 0. So if you're rising any number and you're running 0, then that's going to correspond to a slope of infinity. Okay, so this is one end of the spectrum. The other end of the spectrum is you can also have a perfectly elastic demand. Okay, so special case number 2 is, let's think about a perfectly elastic demand. Okay, what's going to be true about that? Well, in general, if you have a demand that is elastic, then what is generally the case about the demand curve is that the demand curve is going to be relatively shallow in terms of its slope. So elasticity, again, means people are super responsive to price changes. So if you change the price a little bit, you get really big changes in the quantity demanded. So the flatter and flatter and flatter it gets, the more elastic it gets. So if it just kind of like bottoms out and gets to a horizontal line, that's going to correspond to a perfectly elastic demand. So this is going to be an elastic demand. A flat line for the demand curve is going to correspond to a perfectly elastic demand. Okay, now let's think about what that would do to the value that you would get if you calculated the elasticity of demand. Okay, if you have a situation where people are super responsive to the price change, then what that means is you can have like a tiny denominator, and the numerator is going to be huge. So if you kind of push this to the limit and you let the denominator approach 0 and then the numerator approach infinity, then the overall elasticity of demand is going to be equal to infinity, because it's kind of like this denominator is getting smaller and smaller and smaller, so it's kind of approaching 0, and the numerator is getting bigger and bigger and bigger, so it's kind of approaching infinity. And overall, if you have the denominator sinking to nothing and the numerator blowing up, then the overall ratio is just going to blow up. Okay, what about the actual slope of the demand curve? So the demand curve is now going to look like a flat line. What is the slope of a flat line? It's 0. So you're rising, so to get from one point to another point, you rise 0, you run some number, and so the overall slope is going to be equal to 0. Okay, so those are the two special cases. Again, elasticities kind of exist on a spectrum, but at the end of the spectrum, you can have perfectly inelastic demands and perfectly elastic demands. Okay, so let me give you a quick recap in case you like kind of a structured pattern. And then hopefully this will help you just with kind of seeing how all the pieces fit. So let's just do a recap of the cases. Okay, first of all, if you have an elastic demand, or a demand will be elastic if, when you calculate the elasticity of demand, you get a number that's less than 1. You'll have an inelastic demand if, when you calculate elasticity of demand, you get a number that is less than 1. Okay, there's something that's going to be called a unit elastic demand, and that is going to be what we call elasticities of demand that are exactly smack dab equal to 1. So again, this is like the middle of the spectrum, so we're just going to call it a unit elastic demand because elasticity is equal to a unit of 1. And then the end of the spectrum are where we can have perfectly elastic demands, or we will have a perfectly elastic demand if the elasticity equals infinity, so people are super responsive to price changes, and then we'll have a perfectly inelastic demand if the elasticity equals 0, so people are not responsive at all to any kind of price change. Okay, so again, this is memory work. Make sure you know this. And also just note in your own mind that these patterns are specific to price elasticities of demand. So as I mentioned briefly last class, and as you'll kind of pick up on throughout the rest of this class, there are different types of elasticity, so different types of elasticities are going to follow different patterns, but these are the rules that are always true for price elasticity of demand. Okay, so we have all of this, and the question I want you to think about is, who cares? So why does an economist have any interest in what the price elasticity of demand is? So the reason an economist or even a business person would care about the price elasticity of demand is because if I'm a business owner and I think about raising the price of my product, then I'm going to lose some customers probably because, again, the law of demand says if the price goes up, quantity demanded goes down. But how many customers I lose when I raise my price is going to depend on the price elasticity of demand. And so how many customers I lose is also going to influence my overall revenue. Okay, so the question again is, I'll try this out. So what good is knowing the price elasticity of demand, epsilon? Okay, the answer, which I'll demonstrate in a minute, is we like to know the price elasticity of demand because it tells us whether or not a firm will make more money or they'll make less money in total, or this is the same thing as their overall revenue, whether their revenue will increase or decrease if they choose to increase the price of their product. So the answer is epsilon can tell us whether firms will make or lose money if there is a price change. Okay, so to understand this, you're going to need a little bit of background information. So the first piece of information you need is what is total revenue? Okay, total revenue is going to be the total amount of money that a firm brings in sales. So if they are selling goods and each good is being sold for $1 a piece and they sell 100 goods, then their total revenue is $100. So it's just going to be equal to the price that they're selling each good for times the number of units that they sell. Okay, think about these two variables are in the total revenue function. These are the two variables that exist along our axes when we're plotting the demand curve. So when we have a demand curve, we're plotting prices against quantity demanded. And so total revenue is, for a particular coordinate, the price times the quantity. Okay, so this is kind of cool if you think about it. So let's just like pick a point along the demand curve. And let's say that the firm is pricing its goods at this level. That's the price they're selling each good at. And then the demand curve tells us, well, if this is the price they're selling the goods at, then this is how many units we should expect them to sell. Okay, total revenue again is the given price in the market times the given quantity in the market. Well, the price in the market is this amount. So this vertical distance is the price. The quantity in the market is this amount. So this horizontal distance is the quantity. If you take the price times the quantity, that's the same thing as taking the height times the base, or the base times the height, no matter saying either way. So if you multiply these two things, what you're effectively calculating is the area of this rectangle that boxes in the market price and the market quantity. Okay, so total revenue, in other words, is the same thing as an area. So the reason that's important is because the total revenue is going to be sensitive to price changes and specifically how quantities change when you change the price, and that is all wrapped up into elasticity. Okay, so I'm going to give you kind of a preview of the result of how this works, and then I'm going to show you a picture so it's a little bit more transparent. Okay, what's going to be true, I'll label this as truth. What is going to be true is that if the equilibrium price in a market rises, then total revenue will increase if demand is inelastic. Okay, if, however, the equilibrium price in the market rises and the demand is elastic, then there's going to be a reduction in total revenue. So if the equilibrium price in the market rises, then the total revenue that the firm gets will fall if the demand for the product in the market is elastic. Okay, now let me draw you a picture so you can see how this works. So on the board, I'm going to draw two side-by-side demand curves, so it may help in your notes if you kind of leave some space. You can do two side-by-side pictures. We'll start with truth number one, and I'll demonstrate this via artwork, and then we'll go down to truth number two. Okay, let's start with the case of an inelastic demand curve. So what's generally going to be true about an inelastic demand curve is that overall the demand curve is going to be pretty steep. Again, just note back from the first thing that I mentioned that the elasticity, it actually varies across a given demand curve, but overall what is going to be true is that steeper demand curves are going to correspond to more inelastic demands. Okay, suppose, and if you also have color markers, this will help. If you don't, just draw everything very, very carefully. Suppose we have an equilibrium price in the market down here, so it's going to be the blue P. Okay, at this price, we can determine how many units are going to be sold. And so originally in the market, the total revenue for a firm is going to be the area that I'm shading. So it's going to be the product of the market, equilibrium market price times the quantity. Okay, so that's kind of the first thing to note. Okay, now what we know, based on our truths, is that if we're in this situation where demand is inelastic, then if the price in the market rises, then there should be a reduction there should be an increase in the total revenue. So in other words, the new size of the box that we get, the new area of the box should be larger than before. Okay, so we can just test this. So suppose the market price rises to this red P. At this red P, we are going to have a new quantity in the market. And so at this new price, we're going to have a new total revenue area that's going to be equal to the area of the, now the red box. Okay, the thing to note is that the red box is larger than the blue box, which means the total revenue is bigger in the red case than in the blue case. So as soon as the price went up, total revenue increased, and that was because the demand is inelastic. So in other words, the little area that you gave up over here is more than offset by the area you gained up here in the new kind of red space that's shaded. Okay, so we've kind of verified that. So now let's look at truth number two. Truth number two says, if you have a demand that's elastic, then if you raise the price, the total revenue should fall. Okay, so now let's draw an elastic demand. If we have an elastic demand, then overall the demand curve is going to be pretty, it's going to have a small slope. Okay, so if we start out with a baseline market price blue P, then we can figure out how many units would be purchased in the market. It's going to be blue Q. We know that the total revenue for the firm is the price that they sell each unit for times the number of units that they sell, so it's going to be base times height. So the area of this blue rectangle is going to be total revenue to begin with. And now let's think about what would happen to the total revenue if they increase the price from this original level. Well, if they increase the price, then what would be true is that we would get a new price, obviously, and now we'd also get a new quantity. So now, after this price increase, the new total revenue would be equal to the area of this red rectangle. Okay, the red rectangle is smaller than the blue rectangle. That means that in this situation, we increased the price, the total revenue that the firm was getting actually decreased. And again, that was because the demand in this market is elastic. So people are like super responsive to price changes. So if you increase the price a little bit, then you get even bigger reductions in the quantity demanded. Okay, so this is one example of why we actually care about elasticity, because what happens to a firm's sales amount, like total revenue, if they increase the price, is like entirely wrapped up into what the elasticity for the price elasticity of demand looks like for their good. So in situations where they're selling a good that has an inelastic demand, if they raise the price, good news for them. In situations where they're selling a good that has an elastic demand, if they raise the price, bad news for them because they'll actually take a financial hit in terms of their total revenue. Okay, so that's kind of cool. So this is one useful piece of information for today. Okay, now what we're going to do is we're going to think about different types of elasticity. So far we've been thinking about price elasticity of demand. So in other words, if price is the thing that changes, how much the quantity demanded changes as a result. Okay, there's other types of elasticities. So again, elasticities are just kind of this measure of how responsive either quantity supplied or quantity demanded is to a change in something. So other elasticities exist. So another elasticity we're going to think about is the income elasticity of demand. Okay, if you just kind of pick apart these words, you can kind of figure out what this is. So an income elasticity of demand would be a measure of how responsive quantity demanded is when there's a change in a person's income. So the idea is if you give somebody more money, then how much does that influence the number of units that they demand? Okay, we're going to basically calculate this in the same way, but instead of having in the denominator a percent change in the price, now we're not thinking about how things are impacted by price changes, now we're thinking about how things are impacted by income changes. So in the denominator, instead of having prices, we're going to have income levels. Okay, so this elasticity will be calculated as the percent change in the quantity demanded divided by the percent change in somebody's income. Just kind of note, when you're taking econ classes, oftentimes income is denoted Y. So if you see a Y, know they're probably talking about income. I'm going to put I here just so I make sure I don't lose anybody in this class in particular. But if you see a Y, Y also often denotes income. Okay, so here we need to think about like how we would expect these two things to compare to each other in order to like give us some useful information about the elasticity, income elasticity of demand. Okay, when we were thinking about price elasticity of demand, we calculated in the numerator an absolute value of the percent change in quantity demanded over the absolute value of percent change in price, and then we compared that whole ratio to the number 1. Okay, here what we're going to do is we're going to drop the absolute values, and so we want to retain the signs in the numerator and the denominator, and then we're going to take the overall ratio and compare the number that we get from that ratio to 0. And so if we're comparing a number to 0, then we want to know whether the number is bigger than 0, in other words, it's positive, or a number is less than 0, in other words, it's negative. Okay, so just note this. I'll write it out so you make sure you can't forget it. We're comparing this ratio to 0. So note this is a difference compared to the last elasticity. We're comparing the ratio relative to 1. So we don't take the absolute value because we care about the sign. And by sign, I mean whether or not the whole ratio is positive or negative. Okay, think about why we care about the sign. Let's think about normal goods. Okay, so what is a normal good? A normal good is a good where if you give somebody more income, then they demand more units of a good. So this is true of most goods, which is why we call it normal good. So if we calculate the income elasticity of demand for a normal good, then think about whether that whole number for the elasticity would be greater than or less than 0. Well, a normal good says if you take a person's income and you increase it, so in other words, the percent change in income would be positive, then what would happen? They would demand more units, and so the percent change in the quantity demanded would be positive. Okay, if you have a positive divided by a positive, then the overall ratio is going to be positive. So it's going to be greater than 0. Okay, now let's think about the other type of good that we had, which was an inferior good. So an inferior good is one where if you give a person more income, they actually demand less of the good. So the examples we were thinking about were like hot dogs and ramen noodles, where if you give someone more money and you make them richer, they actually cut back their consumption of those things. So if we're thinking about an inferior good, then if you give a person more income, or the percent change in income is positive and it goes up, then what would happen to their quantity demanded? It would go down. So the percent change in their quantity demanded would be negative. So you would have a negative number over a positive number. So the whole ratio would be negative. Okay, so this is why we would ever care to calculate an income elasticity of demand, because when you calculate this and it spits out a number, you can look at that number, you can determine whether the number is positive or negative, and then that tells you what kind of good you're looking at. It tells you whether the good that you're considering is a normal good or whether that good is an inferior good. Just FYI, anytime you're calculating a percent change in something, you can use the same pattern that we had for price elasticity of demand. So specifically, how you calculate this is the numerator would be the second quantity minus the first quantity divided by the first quantity. And then the denominator would be income number 2 minus income number 1 divided by income number 1. So strive to kind of memorize this pattern. Percent changes in anything are just the second value that you have of that thing minus the first value divided by the first value. Okay, so that's another type of elasticity, income elasticity of demand. Another type of elasticity is a cross-price elasticity. So we have income elasticity of demand. We can also have cross-price elasticity of demand. Okay, so what would this be? So this would be a measurement of how much demand changes given a change in the price of some other good that's in another market. So it's the cross price. So a price that's across the aisle of another product. Okay, so a cross-price elasticity of demand is going to have the percent change in the quantity demanded in the numerator, and in the denominator, we're going to have percent change in the price of another good. So we can call this maybe like good A, where we're considering the quantity demanded in good B. So these superscripts are going to denote which good we're looking at. So in other words, this would be like if there's a change in the price of apples, then what happens to the number of units that are demanded of bananas? So we have two different goods in the numerator and denominator. We change the price of one good. We look at what happens to the quantity demanded of the other good. Okay, first of all, so similar to the income elasticity of demand, we're not going to take absolute values because what we want to do again in this case is we want to compare the whole number that we get for the ratio to 0. So note no absolute value because we want to compare the elasticity to 0. Okay. Okay. So there are 2 other definitions that you should recall from a couple of weeks ago. Those are the definitions of goods that are substitutes and goods that are complements. So the idea of substitutes and complements are, for both of these things, we're looking at 2 different goods. So we're considering 2 different markets, but the goods in the different markets are related to each other. If the relationship between the 2 goods is such that they're substitutes, then that means you can use the 2 goods interchangeably. So an example of 2 goods that are substitutes would be pencils and ballpoint pens. So you can, if you need to take an exam, you can use one or the other. You can kind of swap them out. If you're looking at 2 goods and the relationship between those 2 goods is such that they're complements, that means that one good is only useful if you have the other good to use with it. So the example I gave you when we were learning this was CDs and CD players. Like if you don't have any CDs, there's no point in going out and buying a CD player, and vice versa. If you don't have a CD player, don't buy any CDs because you won't be able to listen to them. Okay, so now let's think about how we can use the cross-price elasticity of demand to tell us whether 2 goods are substitutes or complements. Okay, if we have 2 goods that are substitutes, so let's say pencils and ballpoint pens, then if the price of pencils goes up, well, if you're standing in Target and you need to buy a writing utensil and you see that pencils are like super, super expensive, the price is increased, then what do? You just switch over and you buy pens instead. So your quantity demanded of the other good is going to increase because the first thing became more expensive. So you're kind of priced out of this market, so you increase your consumption in the other market. Okay, when this is the case, you're going to have a positive numerator and a positive denominator, so the overall ratio is going to be positive. So when you calculate the number for the cross-price elasticity of demand, it should be a number that is greater than 0. It's positive. Okay, now let's think about 2 goods that are complements for each other. So CDs and CD players. Let's suppose that we're thinking about the price of CDs, and then we want to consider how the quantity demanded changes of CD players. Okay, if the price of CDs goes up, then what does that make you do in terms of players? Well, if CDs are super expensive, you just kind of don't buy as many CDs. So now if you don't have CDs, you quit buying the players because you no longer need them. So if you have an increase in the price of CDs, then for goods that are complements to CDs, you would have a decrease in the quantity demanded of those things. So you would have a negative numerator, a positive denominator. The overall ratio would be negative. So for 2 goods that are complements, the cross-price elasticity of demand should be negative. So when you calculate this and it spits out a number, the number that you get should be less than 0. Okay, so this is why cross-price elasticities are useful. Cross-price elasticities are useful because when you calculate them, they can tell you for the 2 goods that you're looking at whether those 2 goods are substitutes for each other or whether they are complements for each other. Okay, I'm going to stop there for the day, and we're going to finish up this chapter next class. So what you need to make sure is definitely ingrained into your head is what the price elasticity of demand means and what it's good for. It's good for telling you whether or not price increases or decreases would increase or decrease total revenue for a firm. You need to understand the income elasticity of demand, which is useful for understanding whether goods are normal goods or inferior goods. And you also need to understand cross-price elasticity of demand. This is a useful tool for economists because we can use it to determine whether 2 goods are substitutes for each other or they're complements for each other. And again, the only elasticity so far that we've looked at that's required the absolute value is price elasticity of demand. So you've got plenty of things to study up on. If any of this is confusing, let me know in the next 10 minutes, and then after that, we'll meet back for the exercise. Okay, it took a lot of writing to fit the whole exercise on the board, but I think I barely got the top line and the bottom line. It looks long, but hopefully it's not going to be too bad. So the exercise for today is I want you to think about the 3 types of elasticities we have talked about. So for question 1, so you can see if I stand here, suppose you have a farmer and he increases the price of his apples, and so he moves from a price of 1 and a corresponding quantity of 100 to a price of 2 with a corresponding quantity of 40. Okay, the first part of question 1 is you should calculate the price elasticity of demand for apples. You did this in the last exercise, so nothing new here. Part B is based on the elasticity that you get in part A. Answer whether the farmer's total revenue will increase or decrease. So again, as a reminder, whether total revenue increases or decreases depends on whether the demand is elastic or inelastic. Okay, question number 2, we're going to be thinking about income elasticity of demand. So suppose Bill makes an income of Y1 equals $10,000, and he buys an initial quantity of 2 shoes. Okay, after that, his income falls to $8,000, and with an income of $8,000, he buys 1 pair of shoes. So his second quantity of shoes is 1. Okay, part 1 is you need to calculate the income elasticity of demand for shoes. Okay, that will give you a number. With that number, you should be able to answer question 2, part B. And the question is, are shoes a normal good or are shoes an inferior good? So as a hint, you need to take this number and look at whether it's bigger than 0 or less than 0. And then the last question is, suppose we have 2 goods, they're widgets and thingamabobs. When widgets are priced at $2, there are 3 thingamabobs that are sold. So the superscript W stands for widget, superscript T stands for thingamabob. Then when the price of widgets rises, so that the second price of widgets is $6, there are 1 thingamabobs that are sold. So the second quantity for thingamabobs is 1. Okay, part A is what is the cross price elasticity of demand for widgets and thingamabobs. Okay, once you have that number, then with that number you can answer part B, and part B is are widgets and thingamabobs substitutes for each other or are they complements for each other? So again, to answer part B, you need to look at whether you get a positive or negative number for the cross price elasticity of demand. So in total, you're going to need to turn in 6 questions. Admittedly, I know this kind of looks like a lot, but if you're really good on this, then this will be an enormous help for the next exam. So make sure this is all ironed out and clear. And then otherwise, enjoy the rest of your day.